Okay, so let's start. Yesterday we have seen what is cloud computing, okay, and traditional architecture. Then we have seen types of cloud, okay. Now today we'll see how actually the cloud computing works, okay. How actually the cloud computing works. We'll see that. So here you can see the cloud computing reference model. The cloud computing reference model is conceptual model that characterize and standardize the function of cloud computing environments by partitioning it into conceptual layers and cross-sectional layers. Okay, so these five are logical or you can say conceptual layers: physical layer, virtual layer, control layer, service orchestration layer, and service layer. These five are conceptual or logical layers, okay. And these three: service management, business continuity, and security, these three are cross sectional functions, okay. So this is overall the cloud infrastructure, how cloud actually works, okay. So we'll see it layer by layer how all these layers work whenever we use cloud computing, okay. I think the image is clear.
Yes, ma'am.
Okay. So the very first layer we'll talk about is physical layer. Okay. As the name you can see, the physical layer simply means it consists of basically the actual or physical hardware. Okay. This layer actually consists of your physical hardware or which is located inside the data centers, okay. And the physical system basically means you can say computer servers with CPUs, RAMs, network devices. Within network devices you can have physical cables, routers, switches, okay. And these things connects your computer. And you can also have some storage devices, okay. So physical hard drives you can say. Yes. So physical layer basically consists of all your hardware uh, components. Okay. Either it can be used for computation, it can be used for networking, it can be used for storage. Okay. So it includes each and every facility, just like you can say also in physical hardware we also use cooling fans, okay. Power supplies are also there. So this layer basically executes your raw or data processing task, okay. This layer will execute the raw and data processing task sent from upper layers, okay. So let's take an example so that we can understand each layer how it is working. And here you can see the definition is also given, some points are given about the physical layer. It is a foundation layer of cloud infrastructure, okay. It specifies entities operate at this layer, such as compute system, network devices, storage devices, operating environment, protocol, tools, and process, each and everything related to hardware or physical hardware and data processing, okay. It executes the request which is generated by the virtualization and control layer, okay. So this basically executes the request which is generated by virtualization here and by the control layer, okay. So we are seeing opposite, okay. So let's take an example. Let's say ki if you are ordering something online, okay. Let's say you have ordered some food, something from a website, okay, from a restaurant's website, okay. So the customer database will physically must be physically exist on some hardware. Okay, somewhere on the somewhere it is the restaurant server will be placed. Okay, it will be physically present. Okay, so whenever customer click the order pizza, let's say customer is ordering pizza. Okay, so in that case, whenever customer will click on the button order pizza on their phone, that request will travel through the travel through internet cables, or you can say wirelessly it will travel, uh, the data will travel to the physical warehouse where the actually company has owned that database. Okay, that request will travel down to their database, to their physical hardware. Okay, physical servers. Okay, so this is the working of physical layer. Then next we have virtual layer. Okay, this layer is actually installed directly on the top of this physical layer, and this uses virtualization software, or you can say a hypervisor. Okay, to abstract physical hardware. Okay, instead of, you can say, using a physical server as one single machine, what it does, it splits the software into multiple independent or isolated virtual resources. Okay, instead of using the physical servers, what does it do, it splits your software into multiple independent isolated virtual resources, just like VMs. Okay, virtual machines, and they will group them into some resource pools. Okay, resource pools means each and every VMs have some resources, and they will execute the command received from the control layer. So this virtual layer will execute the command whatever it has received from the control layer. Okay, so we have seen the example here. Whenever a customer has clicked on the button to order, the data was traveled down to their databases. Now what will happen in this virtual layer, the cloud provider will not give the restaurant an entire physical server. Okay, they will just do what, they will make virtualization software from one single giant physical server. Okay, and the request will be given to any one of them. Okay, the request will be sent to any one of the virtual machine. Okay, if let's say the request is given to VM1. Okay, we have so many virtual machines, so I'm saying the first virtual machine VM1 means, let's say the request has been given to VM1, but VM1 is busy with some other requests. Okay, so what will happen, control layer will do what, it will send, it will ask virtual layer to send the request to some other virtual machine. So what it will do, the request will go to virtual machine 2. If this machine is free, then it will serve that request. Okay, so they adjust the request. Okay, they serve the request by sharing the same physical machine, by sharing the resources. Okay, the work of this layer is only to serve the request. Okay, see, the deployed on the physical layer, it specifies the entity that operates at this layer link, like virtualization software, resources pools, and virtual resources. It executes the request generated by control layer. Control layer will order, like, which virtual machine will serve that request. Okay, he has sent the request to virtual machine 1, but virtual machine 1 was busy with some other request. So he will ask uh, virtual machine 2 to serve this request. Okay, and if there is no virtual other machines present, then it will create a new virtual machine. Okay, if let's say we have 2 3 virtual machines, but all these virtual machines are busy in serving some request, so in that case what will happen, the control layer will create a new virtual machine and pass that request to new virtual machine. Okay, is this clear?
Yes, ma'am. What is the meaning of ma'am resource pools?
Resource pools means basically each and every like a virtual machines will have some resources to serve the request, na? Yes.
Yes, ma'am. Yes,
Okay.
ma'am.
Now the next thing.
It means
Yes.
it means ma'am more than one request if we send to virtual
Hmm.
layers, it will create it will creates many virtual software, matlab different
No,
virtualizations.
it will not create many softwares. I am saying, let's say if you are there to work, na, so you have already
Yes,
five
ma'am.
requests in a queue. You are working on that request. Okay. So what will happen if there's
Okay.
some new request will come? You will say your partner, na, do this work. I am doing this four request. I am serving this four request. So the control layer will order that go to virtual machine 2. Okay. So in a similar way, if
Okay,
they
ma'am.
are serving some request, but there is like heavy load, okay, there is a heavy load of request. So in that case, it will create a new virtual machine, not for every request. Okay.
Okay.
Yes.
Okay, ma'am. Okay. Thank you.
Hmm. Now the work of control layer. Okay, so control layer will basically it is deployed on either the physical or you can say virtual layer, and it consists of control software. It has control software inside it that configures or manages the cloud resources. Okay. This this layer will either configure or manage the cloud resources. It will dynamically allocates the resources, it will organize them into the pool. Okay. And ensures that delivered that the request is uh, perfectly served. Okay. It will ensure that the whatever request is coming, that should be perfectly served. Okay. So from that example, we have seen that customer is ordering pizza. So firstly, in the physical layer, it was uh, the data was sent to the physical hardware. Then in the virtual layer, what will happen? That data will go to some virtual machine in a queue. Okay. And then in the control layer, what will happen? Control layer will constantly monitor that the traffic is correct or not. If there is a peak traffic, or if there is a like a resources is not available, then in that case it will create a second virtual server, or it will create a new virtual server. Or if there may be a chance that any virtual machine can crash. Okay. Maybe due to the heavy load of request, maybe it happens that virtual machine may crash. Okay. Or some other problem, if any other problem will occur, in that case control layer will do what? It will uh, create a new machine and uh, let that machine to serve all the request. Okay. Next layer is service orchestration layer. Okay. The next thing is what? Service orchestration layer. So what does the orchestration mean? Orchestration word, can you tell me?
Controlling software like controlling software, ma'am. For example, we are controlling the ship in sea, like
Hmm.
a station. These
Hmm.
are called orchestration layer.
Okay. Is there anything else other than
Kubernetes is
this?
the example, ma'am.
Hmm. But you are missing some a single word. You have you have said correct, but you are missing a single word, that is automated, है ना?
Ma'am, where we
Yes,
can
ma'am. Yes, yes.
deploy, automate, build
Yes. Okay.
system like
It
that.
basically means the automated coordination or automated management of complex system or complex task or workflows. Okay. Just like you have said, Kubernetes. So Kubernetes does what? It automatically uh, manage or manage all the containerization. Okay. Means it manages all the containers, Docker containers. Okay. So it is used for orchestration purpose. Kubernetes is used for orchestration purpose. Okay. let's come to this service orchestration layer. Okay, so this layer uh, this layer is built to execute automation workflows, and here we have orchestration software which will execute the workflows automatically. Okay, that means everything will be automated. Okay, instead of like requiring any human engineer to manually configure each and everything by doing it sequentially, the orchestration will do what? It will coordinate multiple uh, distinct automation tools. Okay, it will do what? It will coordinate multiple distinct automation tool to execute some complex setup. Okay, or to process some specific, or you can say predefined instructions. Okay, whatever the instructions were fed into that, it will follow that. Okay, to automate each and everything. Okay, so if let's say like for this, if I will give you an example, let's say a developer like written any code. Okay, let's say he's written an updated code for any website. So it will do what? It will automatically trigger the it will automatically do what? It will trigger the script. So it will directly go to the build, then it will test, and then it will deploy. Na? This is the workflow. Okay, so the work of this orchestration layer is basically to execute the automated workflow. Okay, so it will automatically, you can say also, it will automatically request for a virtual machine whenever it is required from the control layer. Okay, and it can also configure the network firewalls, or it can launch the testing website also. Okay, so basically this is doing everything in automation. There is no manual intervention is required here. Okay, the next layer is service layer. What is service layer? This is the interface where the end user, or you can say the customer, interact with the cloud environment. Okay, so it contains service catalog and self service portal. What is the service catalog? You can say it is a visual list of all available cloud services with their size and pricing and specification. Okay, and the self service portal means you can say a web dashboard or an application interface where user can directly select, deploy, or manage services independently. Okay, so this is basically the interface from where user directly interact with the application. Okay, or you can say application here means basically the cloud application. Okay, or cloud environment, you can say. Is this clear? All these five layers. Is there any problem with this? So actually, I have told you from
No problem.
bottom to top. Okay, from bottom to top, I have told you in a sequence. The in the very bottom we have physical layer, then we have virtual layer, then a control layer, then orchestration layer, and then service layer. Okay. Now let's see these three cross sectional layers. Okay, what are these cross sectional layers? First is service management, then we have business continuity, and the last is security. What is the work of this service management? You can say this handles all the day to day operations or performance. It will monitor everything, it will manage the cloud environment across each and every single layer. Okay, each and every layer is working. Meanwhile, this service management will do what? It will handle each operations, it will it will check the performance monitoring. Okay, it will manage the cloud environment. Okay, and you can say from physical hardware to the front end layer, that means to the service layer. At each and every layer this service management is present to manage everything, okay, to monitor everything. Is this clear? Here we have service management portfolio and service operation management, okay, these two things are present here.
Yes, ma'am.
Hmm. Okay, so now we have business continuity here. Business continuity means what? And business continuity means what? This will ensure that data replication is there na? That means data is copied, there is a backup, a saved backup. Okay, replication means each and everything we are doing, that will be copied to some other place also. Okay, then backup means that copied data will be called as backup. Okay, and the fault tolerance mechanism means, can you tell me what is this fault tolerance mechanism?
Means man, if system gets
Hmm.
fail
Hmm.
by any
By
reason,
any day, huh.
so
Yes.
it can cover through it.
Yes, it can recover each and everything. Okay, if there is any sudden power failure or anything hits your data center, then in that case what will happen? Cloud replication system or this business community layer will do what? It will recover your system, it will recover each and everything from your backup. Okay,
Hello,
without any loss.
hello.
Yes.
Is it a just disaster recovery? Equivalent to disaster recovery, I guess, no?
Yes. Fault tolerance, yes, it is equivalent to disaster recovery also, up to some extent, or there may be some um, power failure, or you can say any like physical component fails. Okay, or system automatically uh, let's say if system crashes. Okay, so these are some situations where it will do what? It will automatically switches to backup copy. Okay, without any crashing or without any loss of data. Okay, then the last layer is security. Okay, the security word, I think you are understanding what is the word security means here. Okay, so this basically implements all the security mechanism like encryption of data, access controls across all layer to protect your data and ensure operation is like legal. Okay, okay, and it will ensure check all the organizational standards also. Okay, so each and everything will be monitored here related to security. Okay, and here we have grc. Can you tell me about the grc? What is grc?
Uh, Hello.
Yes.
GRC is governance, then compliance, and
Mm-hmm.
I just is it like what do you call it? Auditing, something like that.
It is like auditing something. Okay, or is there any other answer?
Regulatory compliance, ma'am.
Hmm?
Regulatory
You
compliance.
regulatory compliance. Okay, GRC basically means governance risk compliance. Okay, governance risk compliance. Okay, the lock and key across your all layers. This will ensure that hacker cannot access your like database storage layer. Okay, so it will protect each and every layer basically. Okay, the security, this comes under the security layer na? So this will do what? It will create a layer so that each and it will take care that any hacker or any other user cannot access any data inside your any layer. Okay, so it will take care about the databases, about the storage layer, or you can say the virtual layer or application layer, any of the layers that cannot be accessed by any unauthorized person. Okay, now so this is all about the cloud infrastructure, how cloud computing works. Is there any problem with this infrastructure?
No, ma'am.
Okay, so let's move to cloud computing environment. Okay, so here we have three type of services. Cloud computing provides you three type of services. Okay, infrastructure as a service, then platform as a service, and software as a service. Okay, there are three type of services. Okay, so very first is infrastructure as a service. Infrastructure as a service provides access to fundamental resources such as physical machines, virtual storage. Apart from these resources, the IaaS also offers virtual machine disk storage, local area networks, VLANs, load balancers, IP addresses, software bundles. All of the above resources are made available to end user via server virtualization. Okay. So basically in this IaaS, what is happening, as the name is also suggesting, infrastructure as a service. Here the cloud provider will rent you all the raw or fundamental computing infrastructures. Okay, or you can say components over the internet. Empty virtual machines will be provided, virtual disk storage will be provided, LANs, VLANs will be provided. Okay, load balancers and static IP will be provided. So user will get full administrative control over the virtual machine, and they can manually install and maintain the operating system. Okay, you can have any type of operating system like Windows, Linux, or whatever you want, and you and any software packages they need, everything will be provided and you will have full control here. Okay, let's see the benefits of IaaS. IaaS allows the cloud provider to freely locate infrastructure over the internet in a cost effective manner. Some of the key benefits are IaaS listed below. Full control over cloud computing resources. IaaS allows computer to access computing resources using administrative rights. Okay, so simply if the cloud provider is providing you each and every components, raw components, so you can manage it on your own. Okay, you will have the full control over your computing resources. You can manage them according to your own requirement. Okay, you can allow them to run any custom software, whatever you want. Okay, or it is easy to move these application to some other cloud provider also. Okay, so it is portable and interoperability also. Okay, here you can see portability and interoperability, the benefits of using IaaS. This is portable and interoperable also. It is possible to switch between application and resources between cloud IaaS clouds. If you have IaaS clouds, so you can easily switch between these clouds. Okay, for example, network applications such as web server or email that normally runs on customer owned server hardware can also run from VS and IaaS cloud. Okay, so these are portable and interoperable also. Okay, now what are the issues with this IaaS? If there is some benefits, so there could be some issues also. Okay, issues, or you can say disadvantage. So compatibility with legacy security vulnerabilities. Okay, because IES offers the customer to run legacy software in providers infrastructure, it exposes customer to all of the security vulnerabilities. What does this mean? I think it is written in an easy language. What happened? You haven't understand this? So, see, legacy vulnerabilities or isolation means simply if you imagine if an engineer install any old software or data old version of a database software, so they will you can say they will expose themselves to some security risk. Okay, and they will rely entirely on the providers cloud service providers software layer to keep their virtual machine safely and isolated from other companies virtual machine. Okay, because they will share the same uh, server na, so that's why there could be security vulnerabilities, there may be. Okay, because you are exposing your secure your software to their VMs. Okay, is this point clear or not? Am I audible or not?
Audible, ma'am.
Okay, okay. Okay, so next point is the VM can become out of date with respect to security updates because IS allows customer to operate the virtual machine in running suspended off state. However, the provider can automatically update such VMs, but this mechanism is hard and complex. Okay, so you can see here virtual machine sprawl means what? This basically means that it is so easy to rent any virtual machine and may that engineer might have let's say they have launched some 5 temporary testing servers but forgot to turn them off. Okay, so in that case what will happen, they will get billed for each and empty resources they have left running. Okay, so this is also an issue with the IS. Okay, then the next thing is data erase practice. Okay, data erase practice means what? The customer uses virtual machine that in turn use common disk resources provides by the cloud provider, and when the customer release that resource, the cloud provider must ensure that next customer to rent the resource does not observe that residue from the previous customer. So this means what? If let's say any user uses any virtual machine they have rented, okay, so customer one is has used that virtual machine, and after their work is completed they have left that virtual machine. Okay, and some other customer came and cloud provider has provided that virtual machine to any other customer. So in that case the common disk resource is used by different customers. Okay, then in that case what will happen, they can see or the customer cloud provider must ensure that the next customer must not observe any data residue from the previous customer. That means they should erase. Okay, they should take care that there should not be any residue of the previous customer. Okay, they should actually you can say they should delete each and everything, firstly completely erase your physical disk and then pass on to the next customer only. Okay, so this can be an issue if you have not If you have not taken care and the provider also has not taken care, then in that case your data may exposed to someone else. Okay, here are the characteristics of IaaS service model. Virtual machines with pre-installed, these are same things that I have told you about the IaaS. Okay, the next type of service is platform as a service. Okay, here in platform as a service, it will offer you the runtime environment for application. It also offers development and deployment tools required to develop application. Okay, PAS has features of point and click tools, enables non-developers to create web application. Okay, so here what is happening, the provider will eliminate all your infrastructure management. In IaaS, what you are doing, you are managing all the infrastructure, all the raw uh, components of the servers. Okay, but here they will eliminate all these things. Okay, they will do what, they will provide you ready to use runtime platform. Okay, over the internet, and it will have pre-configured operating system, it will have database engine, web service interfaces, and built-in development tools. Okay, so in that case user here does not have to manage any servers, they only have to manage their application code, whatever they will write. Okay, you can see here example is also given. App engine of Google, force.com are example of PS offering vendors. Okay, developer may log on to this website and use built-in API to create web based application. Okay, so you can directly use this API to create any web based application. You do not need to worry about the infrastructure here. Okay, what are the benefits here? Following are the benefits. Firstly, low administrative overhead. Okay, because there is no responsibility of managing the infrastructure uh, and the physical servers and the virtual machines. So in that case customer need not to bother anything about the administration. You have only responsibility to manage your uh, application code. Okay, whatever application you are using on that platform, you have to manage that only. Okay, lower total cost of ownership. Okay, customer need not purchase expensive hardware, servers, powers, and data storage. So it will overall lower your total cost, because in IaaS what you are doing, you are purchasing each and everything. Okay, that means you are renting each hardware, servers, powers, network appliances, each and everything. But here you do not need to purchase all these things or rent all these things from the cloud providers. Okay, so it will lower your cost because you are purchasing some less items, so it will lower the cost. Okay, then scalable solution, it is easy to scale resources up and down automatically based on their demand. Okay, in past it is easy to scale down your resources. Okay, whatever resources you are using, you can easily uh, up and down automatically based on the demand. You can easily raise your resources and you can shrink your resources also. Okay, more current system software, it is the responsibility of cloud provider to maintain software versions and patch installation. Okay, so what is the benefit here? It is the responsibility of cloud provider to maintain each and every software version and patch installation, because they are handling the infrastructure. So it is their responsibility to maintain software versions and patch installation. Okay, it is not your headache. That means if you are using PS platform as a service, then in that case it is not your headache, it is the responsibility of cloud provider only. Okay, then the next thing is, what are the issues with this platform as a service? Platform as a service has significant burdens on the customers browsers. to maintain reliable and secure connection to the provider system. However, there are some specific issues associated with platform as a service. The first thing is lack of portability between platform as a service cloud. Although standard languages are used, yet the implementation of platform services may vary. Okay. For example, file, queue, hash table interfaces of one platform may differ from another. As you have, I think you have studied also, there are various data structures, various different type of data structure to store the files. We have different types of queues. Okay, each platform may use uh, different kinds of data structures or different kind of hash tables. There is different kind of uh, various formats are available for storing files and everything. So in that case, each platform may vary, may use different formats, different data structures. So in that case, portability is difficult here. Okay, because there may be possible that one cloud is allowing you the one format, but another cloud is not allowing you to use that format. Okay, so in that case, it will be difficult to transfer your workload from one platform to another. Okay, event based processor scheduling, that means the platform as a service application are event oriented. They have to answer request in a given interval of time. Okay, so there is a schedule whenever you are using platform as a service. Okay, then in that case, applications are given an interval of time, and in that interval of time they have to serve the request. Okay, they have to answer that request. Okay, then we have security engineering of platform as a service application. Since uh, platform as a service applications are dependent on network, they must have to use cryptography and manage security exposures. Okay, so this is also an issue with uh, platform as a service. Okay, they have to use cryptography and some more security exposures to, you can say, here what is written, since ps application are dependent on network. Okay, yes, since you are using, as each and every cloud computing services is depend on the network. Okay, so they are using a different type of cryptography techniques, and they are managing security exposures also here. Okay, now the next thing is characteristics. So actually, yes, ps we have seen browser based development environment. Here actually means what, you have given a platform just like aws na. This is a platform where you can sign up, you can use different type of services here, है ना? So the aws, you can say, is an example of platform as a service. Okay, so this is a browser based development environment. Is it will allow developer to create any database, edit application code either via application programming interface or by point and click tools. Okay, so either you can in aws, either you can use the point and click, that means you can use gui, or you can use Terraform. Okay, you can combine the Terraform to create your whole infrastructure. Okay, using the code. So in that way, you can do both. Okay, so platform as a service provides you browser based development environment. Okay, now the last thing is software as a service. Software as a service model allow you to provide software application as a service to end user. It refers to the software that is deployed on a host service and is accessible via internet. Okay, there are several SaaS application listed below. Okay, so here software as a service basically means this is actually cloud provider will deliver you fully functional complete software over the internet. Okay, here you are getting only the software. Okay, there is no infrastructure available, there is no management of application available, there is no code, nothing. Okay, you are directly provided with a fully functional complete application over the internet, and the application will be hosted completely on the vendor's infrastructure. Whoever is providing you that software, that will be hosted on their infrastructure only. Okay, so user can access it either by web browsing, or you can say directly they can download their application. Okay, they can have like all infrastructure, software version, you can say upgrades, platform responsibility, each and everything here are completely managed by the vendor, or you can say cloud provider. Here you have to do nothing, you have to just use this resource, use this software, you have to manage nothing. Okay, so as we are seeing in IES, we were having full control. Okay, we were having full control over the infrastructure, over the application, over the software. But in platform as a service, we have seen what, there we don't have to manage anything about the infrastructure. We are just responsible for the application. Whatever we are doing, we have to maintain that application only. Okay, but in software as a service, here they are eliminating each and every responsibility. Okay, they are handling each and everything. The cloud provider will handle your infrastructure, upgrades, platform responsibility. Okay, backup, maintenance, security, each and everything here will managed by the cloud provider. Okay, here you can see some examples are given: billing and invoice system. Okay, CRM application, help desk application, or human resource HR applications. So these are examples of software as a service. Okay, here they don't have to manage anything, just they have to access this application and use it, and directly they can use their whatever they are providing, whatever the resources they are providing, whatever the features they have provided in the software, they have to use it. Okay, SaaS makes the software available over the internet. This is the same thing. The license to the software may be subscription based or usage based, and it is billed on the recurring basis. Okay, whatever software you are using, that can be license based, okay, subscription based, usage based. Okay, whatever usage based simply means how much you are using, you have to pay for that. है ना? just like uh, just like in the subscription, you can say Netflix. Okay, you are using how much, if you want to use that application, then only you will pay the bill. Okay, and it is billed on the recurring basis. Okay, if you want to use it again, if you want to use the resources again, then only you will pay. Okay, SaaS application are cost effective since they do not require any maintenance at the user side. Okay, so SaaS application are cost effective, they do not require any maintenance at user side, because you are not responsible for any type of maintenance. Each and everything is maintained by the cloud provider. They are available on demand only. Okay, so what are the issues here? Okay, benefits. So benefits, we have modest tool, directly we are provided with the tool. There is no requirement of any complex software packages client side, there is no risk of configuration. Okay, low distribution cost, there is nothing. Okay, you have to just simply use the uh, software, application software. Okay, efficiently use of software license, the customer can have single license or multiple computer running at the different location. From one single license, user can use multiple computers running at different locations. Okay, Also, there is no requirement for license server because the software runs in providers in infrastructure. Okay, so licensed software, there is no need of licensed software. Okay, this is about the software license, and here it is written licensed servers. Okay, there is no requirement of licensed servers because you are not managing servers. Okay, that is present on the provider's infrastructure only, so they will take care of each and everything. Centralized management and data. Cloud provider will store all your data centrally. However, the cloud providers may store data in a decentralized manner for the sake of redundancy and reliability. Okay, they can either store your data centrally, or sometimes they can also store in decentralized manner. Okay, it's totally depend on them. Okay, because they are not providing you to they are not providing you this to store your data according to your own choice. Okay, you cannot store the data according to you, you do not have any access to their database. Okay, so they will store according to their own uh, scenario. Okay, platform responsibility managed by providers. All platform responsibilities such as backup system, okay, I have told you about this, each and everything will be managed by the provider. The main thing is issue here. Issues, there are several issues with system as a software. Okay, first is browser based risk. If customer visits malicious website and browser become infected, the subsequent access to software as an application might compromise the customer's data. I think you can understand this line, because the software they have provided is a browser based. Okay, or the it may have some risk. If your browser accidentally become infected with some any other malicious website, so your data may compromised here. Okay, to avoid such risk, customer can use a specific browser to access software as an application, or can use virtual desktop also. Okay, to avoid this type of risks, you can use a specific browser. Okay, the next thing is network dependence. Network dependence means what? To use this application, you have to be in network continuously. Means your device must be connected with internet. Okay, also network should be reliable, but the network reliability cannot guaranteed either by cloud provider or by the customer. Okay, so network is not guaranteed by the cloud provider or neither by the customer. This is totally depends on the internet service provider. Okay, how they are providing, what is the speed of the network, this is totally depend on them. It is not depend on the customer cloud provider or neither to the customer. Okay, then lack of portability between SaaS clouds. Transferring workloads from one SaaS cloud to another is not easy because workflow, business logic, user interfaces, support scripts can be provider specific. Okay, so here portability is very difficult because each and everything is provided by the cloud provider only. Okay, you are not managing anything, so to transfer your workload from one to another cloud, it will be difficult for you. Okay, is this clear?
Yes, ma'am.
Okay, okay, just wait a minute. So Okay, so tomorrow we will see the AWS introduction. Okay, and we'll also see the DevOps. Okay, DevOps introduction, and there I'll also show you the how we will move forward. I'll show you the full plan, that how we will see uh, AWS, then we have to see Git. Okay, we have to see Jenkins, we have to see Docker, then Kubernetes. Okay, so I'll show you tomorrow how we'll proceed after this. Okay, and for today I'm stopping here only, and from tomorrow we'll study the AWS and all the DevOps concepts here. Okay.
Okay, ma'am. Thank you.
Okay, ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.